Hey guys, Mr. T here. Your next video for 11 General Maths. This is about electronic technology for finance, so using your graphics calculator basically to answer the compound interest question. So you've seen a whole bunch of formula for simple interest and compound interest, but to save you a lot of time, you use your graphics calculator to carry out more complicated calculations, specifically for compound interest. Okay, you will be taught to use Texas Instruments calculator, so TI-83, TI-84 plus CE, and you can find the application. Okay, because the calculator is essentially like a smartphone, such that you can open little apps on it that do particular things. So find the apps button. It's about halfway down in the middle. When you've opened the apps button, a little menu comes up. Select finance and hit enter. And once you've done that, another menu comes up, and select TVM Solver and hit enter. So once you've done that, you've entered the TVM Solver application, and that allows you to do complex compounding interest calculations. So what you're going to see in this application is this setup here. So you're going to get quite familiar with this. So these are what all of the different variables stand for. N is the number of compounding periods. You've been using N as years so far, but it's important to notice the difference here. It's the number of compounding periods. So if you're compounding more often than once a year, then you have to work out how many compounding periods that is in total. R% is the interest rate as a percentage. PV is the present value, the principal. PMT are any payments. You don't have to worry about that so far, but sometimes you can put an investment in and add money to it as payments, and you would consider that. FV is the future value or final value of the investment. PY and CY. PY is the payments per year, which would only matter if you're doing payments, and CY is the compounding periods per year. For year 11 at this stage, you'll keep these the same as each other. And you also have to double check that PMT is set at end. The importance of this doesn't become important until year 12, basically. Now, this is the basic setup. I just need to add that should be 0, because they've covered it with a black square. That's the default setup. So what you'll find is if you've put in something that's impossible, the calculator says like syntax error or something, an error comes up. So if you're ever not sure about something, return it to this default setup. So make everything 0 except the bottom two, which are 1 and 1, and then you should be sweet. You can start putting in your numbers as you'd expect. So if you have any trouble with the existing numbers, re-enter the zeros for everything and 1s for PY and CY. So the way that you use this application is you enter the details that you do know from the question. So everything you know from the question you put in, and then you highlight the thing that you don't know, the thing that you're trying to find, then press Alpha Enter on your calculator, and that solves for that highlighted variable. It tells you exactly what it is. One thing to note, when you're using this application, and if you're going to go into year 12 subject of this where you're going to use this a lot more, this app is from the perspective of the user, so whoever's using the application, the investor. So you have to be careful about how you're entering PV, PMT, and FV. Their sign changes depending on which direction the money is going. If the money is leaving you or being put away, even if you're investing it, you're not holding on to the money. You're putting it somewhere. The PV, PMT, and FV will be negative. So you have to think about the direction the money's going. If the money is coming to you, so you're getting the money or earning it, then PV or PMT or FV are positive. So I'm not saying all of these are going to be negative, all of these are going to be positive. They're going to change sign based on which direction they're going. Okay, so hopefully I can show you what all that means when I do an example. So this first example, I've already answered it, so I can talk through, and I can point out the things that I knew and what I put in. So what final value would an investment reach if the initial investment was $10,000? So you put 10,000 away, place it in an account compounding at 5% per annum, compounding monthly for 5 years. So you're putting $10,000 in an investment account that compounds monthly at 5% per annum, compounding for 5 years in total. So here, because your calculator is doing all the working out, you need to have a way of showing you're working out so you can get marks for it. So when you're using TVM Solver app, this is how I want you to show you're working out. You're basically going to show all the variables and put a star next to the variable that you're finding. Okay, so n in this case, is that one of the things we know? Well, we know that it's for 5 years and we know it's compounding monthly. So we have a way of working out what n is, the total number of compounding periods. Because if it's for 5 years and it compounds monthly, 5 lots of 12 months is going to be 60. So that's why n is going to be 60. 5 years compounding monthly, so 5 times 12 compounding periods. We know what the interest rate is, it's 5%, it's told directly, so put 5 there. PV. So this is the first consideration with the negative. We are putting $10,000 away. We're putting it into the bank, into a bank account. So it's not just going to be 10,000, it's going to be negative 10,000 because the money is being put away into an account. PMT is going to be 0 because we're not making any payments. That's clear from the question. It just says you're putting 10,000 away and letting it grow. FV, I'm not going to put that straight away because I'm just going to put a star there because this is star to indicate you're solving for that. We don't know that yet. That's what we're trying to find. And then payments per year and compounding periods per year. We're going to keep them the same for this year. But because it's compounding monthly, it's determined by CY, compounding periods per year, 12. And so PY is also going to be 12. So now you would, on your calculator, select FV. You would highlight it using the little arrow buttons on the right hand side of your calculator, and you would press alpha enter and just let me do that as well. So I'll go to apps, finance, TVM Solver, change n to 60, I is 5, 10,000. You must be careful as well when you're putting negative numbers in. So negative 10,000, you do not use the take away sign, which is on the extreme right hand side of your calculator. You need to use the little negative sign, which is a little take away sign in brackets at the bottom to indicate negative 10,000. Otherwise your calculator is going to freak out, okay? So hopefully that avoids some things. I should write that there. Need to use negative sign button, and so that looks like this. I always draw my buttons with a circle around them to make it easier for you when I'm explaining. So it's in brackets and it's a little take sign. Okay, when you're using this particular app. So PMT is 0, FV we're working out, PY and CY are 12. So I'm going to highlight FV on my calculator, press alpha, enter, and it says FV is going to be 12,833.58679, so it would round up to 59. So that's telling me that after 5 years, compounding monthly at 5% per annum, that $10,000 is going to grow to $12,833.59. So that is a pretty much given example. I just want to work through one with you now. And this one is going to be a bit more complicated because it's working out what n is. So how long we need to put the money away for it to grow. So here, this is a working out, TVM Solver, to indicate that we're using the calculator. So it's going to be n, put the variables down, PV, PMT, FV, PY, CY. So this is how you would work it out and write it down in your books and your tests, whatever. So what do we know? Well, we're trying to work out how long it needs to be invested for. So we're solving for n. So put a star next to that. Do we know what I is, the interest rate? Yes, it's 6.45%. PV, do we know what the initial investment's going to be? 4,000. We're going to put away 4,000, but are we holding onto that money or are we putting it away somewhere? You're putting it away somewhere, so you need to make this negative. PMT, are we making any payments during the duration of the investment? No, so there's 0. FV, so we're not solving for FV, we know how far it needs to grow. It needs to grow to 10,000. So that is 10,000 straight up, no negative sign, because you're getting that money at the end. PY and CY, well, here the only thing that we know is it's compounding half yearly, so it happens twice a year and you're going to keep PY the same. So enter all of those details into your calculator. Negative 4,000 for PY, PMT is 0, FV is 10,000, and then PY and CY are 12. So now I'm going to highlight N and go alpha solve, and that comes up with 28.87 to 2 dp. So that's telling you that's not 28.87 years that you need to put in. That's ridiculous. It's 28.87 half years, because it's compounding half yearly. So if I wanted to work out how many years that is, well, half years is 2, so 2 per year, so 28.87 over 2. It's going to be 14.435 years. And you only need to do it as accurate as the question asks. If it just asks you how long, well, this would be a perfectly acceptable answer. If it asks for it in years, then this would be a perfectly acceptable answer. If it asks you for years and months, then you need to do the extra steps. So like 0. So yeah, you know it's 14 years. How many months is 0.435? It's not 4.35 months. 0.435 is the fraction of a year that you have, and you know that there's 12 months in a year, so times by 12. So 0.435 years is actually 5.22 months. So 14 years, 5.22 months. And you could go on with this, you could work out how many days this is. Right, so that's just an example. You only need to answer it to the accuracy that the question asks you to. So that is using the calculator for compounding interest questions. Hopefully that helps you out, and I'll see you on the next video.